Hi, I'm Chris, and this is the 3D Primer tutorial for Adventure Creator. This is going to be using Unity 6.2 and Adventure Creator 1.85. If you followed previous versions of this tutorial, it's going to be largely similar, just updated for more recent versions of AC. And you can see from this little preview, we're going to be making a game that involves Tin Pot and Brain from the 3D demo, where we try to rescue Brain from a little bit of danger he's gotten himself into. Starting with a fresh Unity 6.2 project set up for URP, and going to the Package Manager, I'm going to import the latest release of Adventure Creator. And in the dialog box, this is just personal preference, but I'm going to uncheck the 2D demo and demo folders from being imported, just so that we don't have any models and assets that we're not going to be using. After importing, we now have the Adventure Creator folder in our Assets directory, as well as the Adventure Creator menu in the top toolbar. From here, I'm going to choose Online Resources and then Downloads. And on this page, we can find some tutorial assets files that we're going to make use of. After downloading, I'll be back in Unity and choose Assets, Import Package, Custom Package. And after selecting tutorial files, we'll then get the dialog box to import this as well. This tutorial files is a little bit similarly named to the tutorial info that came with this project, so I'll just remove the latter to avoid any confusion. Inside tutorial files, I'll click Evil Lair and then open up the Evil Lair scene file. You can see we've got quite a big space to work with, and it's themed around a typical 60s style Bond villain's base. We've got a giant death laser here pointing right at this table, and a lift to one side and a coffee table to the other. To get started with any game using Adventure Creator, we just need to visit the New Game Wizard. We can access this from the top toolbar and choose Adventure Creator, Getting Started, New Game Wizard. This will help us set up our game's initial assets, and it works by asking us just a few questions about what kind of game we're making. So I'll choose Begin and then New Game. We'll then need to name our game. I'll type in 3D Primer. Next, we'll choose our game's perspective. This is going to be a 3D game. Next, we have movement, and it is worth mentioning that all of these settings can be changed at any time later. But for this tutorial, we're going to be making a direct control game. Next, we'll choose our input. This is going to be with mouse and keyboard. For the interactions page, we can choose the way in which our game's hotspots are interacted with. We'll go through each of these as part of the tutorial, but to begin with, I'll choose the most simple, which is context sensitive. This will then bring up the templates panel, which gives us a selection of starting templates that we can optionally import. As we're going to be relying on assets we've just downloaded, we're not going to need to rely on the 3D sample player or scene templates, but we are going to be relying on input system, as this is the default way of handling input for Unity 6. And just to make things a little bit more cinematic, I'll import cutscene borders as well. On the last page, we then get a chance to review our choices. And all I'll change here is the default interface field from Adventure Creator to Unity UI. And that'll just mean that Unity's own UI system is used to render our menus. I'll then click Create, and after a few moments, we're then told that the process is complete. And if we look in the project view, we have 3D Primer, the name of our game, as a subfolder. You might have seen I just clicked away the AC game editor, so I can bring this back by going up to the top toolbar and choosing Adventure Creator, Editors, Game Editor. This window works best when docked vertically, so I'll take the tab here and just dock it beside my inspector. The AC Game Editor is made up of 8 tabs, each of them representing a different manager. So for example, we have the Settings Manager that controls all of the main settings, from how our player moves around to our camera's aspect ratio, and the Inventory Manager, where all of our items are defined. But for now, we're just going to go to the Scene Manager while we set up our scene. To convert a regular Unity scene into one that AC can work with, we just need to go to the Scene Manager and choose to organize it either with or without folders. If I click with folders, you can see these are just empty game objects that can be used to help keep things organized, but I personally prefer to do it without and just organize things as I go. As a bit of housekeeping, I'll right-click and create an empty named Lights, and just use this to put the 3 light objects in. And then I'll save this as a new scene by going to File, Save As. And then also adding it to the build settings so that it appears when we build the game by going to File, Build Profiles, and clicking Open Scene List, add the open scene, and I'll get rid of the sample scene from that as well. This scene has already been set up with colliders for its floor and various walls, so we can now get started with adding a player character. We can find some graphics for this player character inside the tutorial files folder, and then within Evil Layer and Tinpot, we have this el_tinpot model file. So let's drag him into the scene here, and I'll clear his position. And all he is at the moment is just an animator with a skinned mesh renderer, and we can use AC's character wizard to convert him into a player. With our model in the scene, we can go to Adventure Creator, Editors, and then Character Wizard. And then, just like with the New Game Wizard, this is just a case of filling in all the details that it asks for. So this is going to be a player. Next, we have a base graphic to assign, and this needs to be an object within the scene. And I'll name the character Tinpot. Next, we want to choose the type of motion control, and I'll leave this as the default character controller. This is now finished, and we can see we now have a fair few number of additional components added. And we can test this out by entering play mode, but first I'm just going to make sure that the main camera is in a more suitable place. So if I select the main camera and move my view up to about, say, here, go to Game Object, Align with View, and now we can enter play mode and get a good view of where the player is. Because we're in direct control mode, we can move him around using the cursor keys or WASD. And if we press left shift, we can have him run around. I'll adjust these values slightly. I think he's running a bit too quickly. So if we select him and find his player component, we can see that his run speed scale is currently set to 6. So I'll try maybe 4. And maybe slow his walk speed down to about 1.7. These changes will be undone when we exit play mode, so I'll just go to the top of this component and choose Copy Component, and then use the same button to paste component values. If you find that your character isn't moving around when you use the cursor keys, the first thing to check is that they don't have Apply Root Motion enabled in their animator. If this is enabled, then AC will expect that we have root motion animations applied, which will mean that they don't move if this is not the case. We're able to use direct control to move player characters around with just colliders on the floor, but if we want characters to be able to pathfind, for example during cutscenes, or if we're using point-and-click movement, then we'll need to set up a nav mesh. To do this, we'll first need to make sure that we have Unity's navigation package installed, which we can do by going to the Package Manager, and then in Project, checking that we have the AI Navigation package installed. If we don't, we can just get that from the Unity registry. We can then add a nav mesh to our set here, so I'll click on Evil Layer, and then adding the component nav mesh surface. I'll want this to gather up all of the children in this hierarchy, so I'll set the object collection to current object hierarchy, and I'll include all layers. Clicking Bake, you can see we then have this blue nav mesh to represent where characters can and cannot move to. which means we'll be able to move characters during cutscenes. But for point-and-click pathfinding, we just need one more step, and that's just to place the floor here, this is the platform game object, onto the nav mesh layer. So if we now enter play mode, we can change to point-and-click just by going to the Settings Manager, and then underneath Interface, I'll set Movement Method to point and click. Any field within the Settings Manager can be changed at runtime, either by changing options within this window or by right-clicking on the label and getting an API reference to control it through script. But for this tutorial, I'm going to switch back to Direct. Let's now get our player character animating as they move around the scene. And to do that, we'll need to create an animator controller asset. Inside my 3D Primer folder, I'm going to right-click and choose Create, Animation, Animator Controller, and I'll name it Player. Then selecting the player's root, I'll drag this into his animator's controller asset field. We can then double-click this to bring up the animator window, and we have some animations we can make use of by reselecting the model file from the tutorial files package. If I expand it, you'll see that we've got robot idle, walk and run animations, and we'll transition between these using a blend tree. So I'll right-click in the animator and choose Create State from New Blend Tree. I'll name it Motion. And then double-clicking that, we'll have the blend tree itself. So I'll create 3 new motion fields. And I'll assign each of the animations into these motion boxes. So idle up at the top, walk in the middle, and run at the bottom. You can see that these are driven with a new float parameter named blend, and I'll rename this to maybe move speed. To have AC control this at runtime, we just need to go back to our player object, and in the player component you can see we have a set of mechanim parameters, and any of the values here will be controlled by AC at runtime. So for example, we have our move speed float parameter, which at the moment is called speed. So if I rename this to move speed, which matches our animator, then AC will set this value to the character's speed at runtime. This value will transition to his walk and run speeds, which we've set to 1.7 and 4, and I'll use these to set the blend tree's threshold values. So if I reselect our blend tree, uncheck Automate Thresholds, I'll set the run threshold to 4 and the walk to 1.7. If we now run the game again and try moving around, he'll transition between his walk, idle and run animations as he moves. Going back to his player inspector, you can see we also have a talk bool parameter named isTalking, and if we create this in our animator, it'll be set to true whenever the character speaks. So I'll click the plus icon in the animator, choose bool, and name it isTalking. Go back to the base layer, and we have a robot talk animation that I'll drag in underneath motion. I'll create a transition between the two. From motion to talk, I'll uncheck has exit time, create a new condition that is isTalking is true, and I'll do the opposite as well. Now we don't have any speech in our game just yet, but when we do, our character will then play their talking animation. Controlling where our player character begins the scene from is a case of affecting the player start, and we can see this listed in the Game Editor's Scene Manager. Underneath Scene Settings, we have a default player start field, and if I ping this in the hierarchy, you can see that it's represented by this blue arrow here, and I can move this over to maybe say by the lift doors here, and then rotating it away from the doors. This nav mesh is getting in the way here, so I'll click on the navigation button and just check Show Only Selected. If we're making a game with many different scenes, we probably want to use a player prefab rather than having our player character be part of the scene file. And we can do this by first creating this prefab. So I'll take the player character, drag him into our 3D Primer folder before removing him from the scene. And we can then respawn him at runtime by going to the Settings Manager and underneath Characters, assign the prefab in the Player Prefab field. And if we now run the scene, we'll find that our player is now being spawned at runtime by the lift doors, which is where the player start is. Now that our player character can move around the scene, we can work on a camera system so that we can keep the player in view as they move around. Inside the Scene Manager, we can scroll down to the Scene Prefab section, and then we have a series of subsections for different prefab types. The first of these is Camera, where we can click different camera types to add them to the scene. The most simple of these is the stationary camera, and this won't move at all unless we attach a custom script. We can add it to the scene and position it a little up and maybe facing towards the lift. And we can then make sure that this is active when the scene begins by assigning it as our scene's default camera, just underneath the default player start field. The next camera type is the standard one, and this one can move. If we have a look at its inspector, you can see we've got options for various position and rotation axes. So for example, we could position it up a little over here. Again, make it face where the default player start is. And then have it move along the x-axis as the player does. So I can uncheck the lock under x-axis movement, make sure that this is affected by the target x position, the target being the player by default, and then again assign this as the default camera. While in play mode, we can change which camera is active by using actions, and we'll go into actions a bit later. The next camera type is third person, and this allows for a more modern over-the-shoulder camera type that the player can control by moving the mouse. We'll go over this in more detail later, but for now we're going to work with the array camera type. The array camera type is a little bit more complex than the others, but it allows a lot greater control over rooms where the set geometry is a bit more complicated and we want to control exactly where the camera is depending on where the player is. I'll create this by clicking and then assign it as the default. And if we expand it in the hierarchy, you'll see we've got a camera node object. This is a regular camera with a camera node component, and what we can do is position this where we want it to be when the player is, for example, at their player start. Because the camera component is active during edit mode, we can go into the game window and preview what this is going to look like. So if we imagine the player is standing at the player start, I'm going to rotate the camera, maybe pull it back a little bit, like so, and rotate it downward a little bit as well. To have this node be active when the player is at the player start, we need to affect the target position field. At the moment, this is set to 0, 0, 10, which is a global coordinate, and you can see is represented by this arrow here. So we can drag this over towards the player start, and this then tells the camera that this node should be active when the player is at this position. We can then go ahead and duplicate this node, and next let's move the target position over to this corner, and now we can control where this camera is going to be when the player is at that position. I'll do the same for up on the left, over by the maybe by this seat. And you can see it's a bit of an involved process, and so I'm not going to take too long refining it as part of this tutorial. But the idea is that the camera will interpolate between each of these different node positions. And so the more nodes we place down, the greater control we'll have over the camera's exact position anywhere in the scene. I think as the player starts to get towards this corner, I'll start to lift the camera up and maybe point it down so we can still keep track of the player. And let's see how this feels now. It's looking pretty good, but I think we need a bit of work when he's around this panel here. So let's come out of play mode, and I'll just place another one or two nodes down here as well. I'll duplicate this one, move the camera, maybe say around here, and then the target position over by the panel. You can take quite a bit of time to refine this if you like, but the principle is essentially the same. Now that we can navigate the scene and have the camera follow us, let's make a few interactions so that we have something for the player to do. We can start simple and have a look at this chair here. If we select the chair and then go into the Scene Manager, further down the Scene Prefabs panel, underneath Logic, we have a Hotspot option. Hotspots are how we make objects interactive, and if we click on it to create a new one while we have an object selected, we'll have the option to automatically position it over that object. So I'll choose Yes, and we now have our hotspot represented by this yellow cube. Going to its inspector, I'll name the object Hotspot Chair, and we can access the properties of the hotspot further down. We can set a name for it that appears when we hover over it, and I'll call this Chair. And ignoring the others for the moment, we can have a look at the interactions themselves. At the moment, we're using context-sensitive interaction mode, which means we can left-click to use an object and right-click to examine it. So we can create a new use interaction just by clicking the plus icon, and then clicking the plus icon again for the interaction field. This then creates an interaction object, which we can see in our hierarchy, and I'll parent this to the hotspot itself. And you can see that both in the hierarchy and the inspector of the hotspot, we have this little node icon beside it. If we click on this, it will bring up the Action List Editor window. And the Action List system is Adventure Creator's visual scripting system, and it lets us dictate what happens when we've clicked on it. By default, this is just engine wait, but we can have the character say something by changing it from engine to dialogue and then play speech. We want the player to say something, so I'm going to check player line, and then the line text will be something like I can't sit down, I don't have a butt. Going back to the hotspot inspector, we have this player action field, and here we can choose what the player does just before this interaction runs. So for example, if we want the player to face this chair, we can just set it from do nothing to turn to face. Similarly, we can create an examine interaction just by clicking the plus icon, and again I'll choose turn to face, click on the plus to create a new interaction, open up the action list editor for it, and again we'll have a play speech action where the player says it's got a nice view of the action. I'll give it that. We can test this by playing the game, and if we move over to the chair here, we can left click. Actually, I'll face away so we can demonstrate the player action. If we left click, he'll turn around and say the dialogue text, and he'll give different text if we right click. You can also see the cutscene borders appearing whenever we enter a cutscene, and this is because we installed the cutscene borders template as part of the new game wizard. I'm using the mouse buttons to interact with this, and if we go to the Game Editor's Settings Manager, underneath Interface, we've got our input method set to mouse and keyboard. If we wanted to change this, so for example, we could press the E key to look at something, we can do so with either of these top two inputs, and then defining an input named Interaction A. If we scroll further down to the input panel, we'll get a list of all of the available inputs to us that we can then define and make use of in our game. Let's make another hotspot now, and this time we'll make this laser over here interactive. This laser is going to be animated at runtime, which means it's a skinned mesh renderer, and so we don't have the option to auto position it for that. So I'm just going to create a hotspot in the center of the scene and then name it laser, and then use the scene controls to reposition it up and rotate it a little bit and then stretched out. A hotspot's interactivity is based on its collider, and by default we use box colliders, but we can remove this and replace it with a capsule collider if that's a better fit. Again, I'll set the label to laser and create a new use interaction and an action list to go along with it. As before, we'll choose a dialogue play speech action in which the player says something like, "Looks dangerous. I'd better keep away." For the player action, I'll set this to walk to, just so that he takes a few paces towards it before this interaction runs. Now that we have our player character able to interact with a couple of hotspots in the scene, we can make things a little bit more dynamic by having him turn his head to the various hotspots when we hover over them. For a character to be able to turn their head dynamically, we'll need to make some changes to their animator. If we go to our player's prefab, scrolling down the player component, you can see we've got this Use IK for head turning option. And in the case of humanoid characters, we can check this, then go to their animator, and in the base layer, enable the IK pass option. And for humanoid characters, this would then be enough. Unfortunately, Tin Pot here is not a humanoid, and by that I'm referring to his rig. And we can check this by going back to his model file, and in the rig tab, we've got the animation type set to generic. And for this type of 3D character, we're instead going to have to rely on a 2D blend tree inside our animator. If we return back to the player's inspector, I'll uncheck this option, and we'll then get another couple of mechanim parameters that we can make use of: a head yaw float and a head pitch float. In the head yaw float, I'll type head X, and for head pitch, head Y. And then in the animator, under the parameters tab, I'll create two floats by those same names. And we'll put some new animations in a separate layer to the base. So I'll go back to the Layers tab, click on the plus, name this Head. I'll set the weight to 1 and the blending to additive. We have some animations to play if we expand the model file, and you can see we've got look down, left, right and up animations. We'll play these in a blend tree, so I'll right click and choose Create State from New Blend Tree. I'll set the blend type to 2D Simple Directional. The parameters are going to be head X and head Y. I'll click the plus icon 4 times to create 4 motion fields, and then drag each of the look animations into these fields. For look down, we're going to have an X of 0 and a Y of -1. Look left will have -1 and 0. Look right will have +1 and 0. And look up will have 0 and +1. So that's our player set up with head turning. We can have him turn his head automatically as we hover over each of our hotspots. And we can do this from the Game Editor's Settings Manager, scrolling down to the hotspot section and just checking player turns head to active hotspot. And you can see when we hover over the laser, he looks up, and over the chair, he looks to the right. We can also control head turning during actions. So if I open up the laser action list we made earlier, right click in some empty space to choose Add New Action. We've got a character face object action, and if I set face width to head, we can use this to turn a character's head to a specific object. We also have the ability to turn characters' heads during timeline using Adventure Creator's custom timeline tracks, but we'll be going over timeline a little bit later. The centerpiece of this scene is obviously this giant laser here, so we can make things a bit more interesting by having it point towards someone that we need to rescue. Inside the tutorial files, Evil Lair and then Brain folder, we have this el_brain model file. If we drag him into the scene and clear the position, you can see that gives us a character that's strapped to this table now. The legs are looking a little bit wonky, but that'll sort itself out once we add the animation. So we can convert this to a character just as we did before by using the character wizard, which we can access by going to the top toolbar and choosing Adventure Creator, Editors, and then Character Wizard. This time we're going to be making an NPC. The base game object is going to be this model, and I'll name the character Brain. This character isn't going to be moving around, so I'll keep the character controller as the default value here, but then remove the component later. So with that done, you can see we've now got an NPC component added to this character, and it looks quite similar to the player component we've been working with. Underneath the mechanism parameters, we have move, speed, float and torque ball parameters, and if we expand the model file here, we've only got a few animations to work with, and we're going to play these manually as opposed to running them automatically, so I'm going to remove the speed and is talking parameter names. For these animations, we're going to be relying on an animator controller, so back in the 3D Primer folder, I'll choose Create New Folder, name it Brain, and I'll create a new animator controller, also named Brain, and the default animation state here will be Brain Trapped Idle. We're going to have him turn his head. If we expand the preview here, we have an animation where he just turns his head to the left, where the player is going to be facing him. And so we can transition to this using a bool parameter. I'll drag this into the controller and then create a new bool parameter named isLooking and transition to it from our default state, setting isLooking to true and isLooking to false for the return. Going back to our model in our scene, I'll assign this controller in the animator component and uncheck Apply Root Motion. Scrolling further down, We'll remove the character controller because he's not going to be moving around. And you can also see we have a hotspot component on his root, and this is going to be located at the origin of this character, which is actually in the middle of the scene here. And this is normally fine for characters that are positioned where their origin is, but in the case of this character, I'll remove the hotspot and add it as a child so that we can position it better over the character. I'll go back to the scene manager, click on hotspot, and name this maybe hotspot brain, and then just position and rotate so that it better fits. Then I'll just make this hotspot a child of our character, and then make the whole thing a prefab. Having a look at the hotspot brain inspector now, we can scroll down and click on the plus icon to create a new user interaction, and this time we're going to set the cursor icon field to talk to. The various icons that we're presented with here can be set in the cursor manager, and with this interaction method, this just controls which icon appears when we mouse over. When we speak to Brain here, we're going to have him turn his head to the left a little bit, and so we're going to have the player be positioned around here so that it matches up. So for this, we'll set the player action to walk to marker, which means that the player can walk to a specific position. We'll get a warning box saying that we need to define such a marker, and we can do that just by clicking the plus icon up above where it says walk to marker. I'll position this, giving it a Y position of 0 and moving it to, say, around here, maybe rotating it as well. And going back to the hotspot, I'll check face after moving, and then create an interaction action list. To make this interaction a bit more cinematic, we can cut the camera to one that frames our two characters better, and we can do that by going back to the scene manager, and this time I'll create a stationary camera. I'll name this camera brain, and I'll position it so that it'll be over the shoulder of our player character as we're talking to this character. I can temporarily enable its camera component so that I can get a preview in the game window, and I'll maybe raise it up and lower the field of view a little bit. We can now go to our Talk to Interaction action list, and the first action we're going to run here is a camera switch action. And we'll use this to switch to our new camera brain camera. If we leave the transition time as 0 seconds, it'll be a snap cut. And next we're going to have our NPC turn their head. We can do this by setting our isLooking bool parameter to true, and we can do this by running a character animate action. Our character is going to be brain. The method will be change parameter value. The parameter to effect will be isLooking, and the parameter type bool, and we'll set as value true. We'll have the player maybe say a quick line before we do anything else, so we'll run another dialogue play speech action in which our hapless NPC says the line, "Hey, little help." We can give the player a choice of dialogue options to respond with by creating a conversation object. This too is available in the scene manager. Underneath logic, I can click to create a new conversation, and I'll name this conversation brain. And looking at its inspector, you can see we've got a list of dialogue options that we can create. So I'll create 3 of them, and selecting each one will bring up its properties. The only property we're interested in right now is the label, and this is what will display when it's on screen for the player to choose. So I'll set the first label to "How'd you get into this mess?" The second will be "What can I do?" And the third, "Don't go anywhere." And this will be our exit conversation option. We can ignore the rest of these and just go back to the action list, creating a new action. This time it's going to be a dialogue, start conversation. The conversation is going to be this brain conversation we've just made. And if we check override options, we'll then get the 3 options that we've created listed underneath. You can see we've got these socket icons beside each of these, and this means that we can drag out the responses directly within this same action list. So for this how to get into this mess, I'll create a new dialogue play speech action in which the player repeats that line. So I'll copy the label and paste it into the line text. And then we'll have another play speech action, this time coming from Brain, in which he says, "Guess I found the wrong place to take a nap." We can have the game return to these conversation options at the end of this chain just by dragging this output socket back onto our dialogue start conversation action. I'll do something similar for these other 2 responses. So for the what can I do, we'll have the player say just that. And Brain will respond with, "Turn off that laser, will you?" Again, returning back to our conversation options. For the third, we'll say, "Don't go anywhere." And Brain can respond with maybe "ha ha." This time we won't reroute back to the conversation action, and this will mean that our interaction can end. But first we'll just undo the camera and animation changes that we made at the start of this. So I'll marquee select these first 2 actions, right click and choose copy selected. And then on the dialogue play speech action, I'll click on this cog icon and choose paste after. Then for this camera switch action, I'll check return to last gameplay and maybe set a transition time of say 2 seconds and set the move method to smooth. We'll also revert his animation, so this time we'll set the isLookingBall to false. And one last thing I'll do before we test is just go back to the hotspot brain object, and in the hotspots label if not name field, I'll just set this to the name of our character. So if we now run the scene, we can move over to Brain here. If I click, our character will walk up to the marker. Our camera is a little bit high, but we can tweak it later. And you can see we've now got the 3 dialogue options that we can choose from. And if we choose any of these, the characters will respond in the way that we dictated. And if we choose the last one, then the action list will end. We can make this conversation a little bit more interesting by having the second option only show up after we've chosen the first. To do that, we can go back to our conversation object, and if we select the second option, I'll uncheck is enabled to make sure that it's hidden by default, and then back in our action list. And at the end of our chain of actions for the first response, I'll click on the cog icon, choose insert after, and that'll just create a new action in between. And I'll set this to be a dialogue toggle option action. The conversation is going to be conversation brain. The option will be what can I do? And we'll be setting it to on. And this just means that the second option won't run until we've chosen the first. The main puzzle for this little game is going to be to turn off the giant laser here, and so to help remind the player, we can have Brain here call out to the player as we're moving around. First though, we want to keep track of whether or not this laser is on, so that when we turn it off, our gameplay logic will react to it. If I click on the laser gun object we have, and then choose Add Component, I'll choose Adventure Creator, Logic, and then Variables. And variables are essentially a way of keeping track of data at runtime. So if we click on Create New Component Variable, we'll then get a label. We'll name this isLaserOn. The type will be Boolean, and the initial value will be true. We can then use this within our action lists to change what happens accordingly. So if we now make a cutscene where Brain will be calling out, we can do that back in the Scene Manager. Underneath Logic, I'll create a new cutscene, and I'll call this Brain Background Speech. If I then open up the action list editor for it, I don't want anything to happen if the laser is off. So what we can do is set this first action to a variable check action, and we then have to choose the source, and we have three options. Global refers to variables that are game-wide, local refers to variables within a specific scene, and component refers to variables that have been defined in the way we just did. For global and local, we can edit these within the Variables tab of the AC Game Editor, but here we're going to be just choosing component, and the component is going to be the one on laser gun. The variable we're going to be checking is isLaserOn, and we'll be checking if it's equal to true. So if the condition is met, we're going to maybe wait a few seconds. So I'll choose an engine wait of maybe say 4 to begin with. And then we're going to have Brain say something. So I'll create a new dialogue play speech action in which Brain says something like, "Get me out of here." We can then loop back onto this variable check at the end of it so that it just runs continuously until isLaserOn becomes false. By default, action lists will block gameplay, and we can change this by going to the Properties tab and changing the When Running field from Pause Gameplay to Run in Background. To have this action list run when the scene begins, we have a couple of options. The first is to go to the Scene Manager and assign this as the On Start cutscene underneath the Scene Cutscenes panel. But I personally prefer to leave this field for introduction cutscenes, and we'll do this a little bit later when we create one. So the other way we can run this action list when the scene begins is to just go back to its inspector and add a different component, this time Adventure Creator, Logic, and then Action List Starter. And then just checking Run on Scene Start. We can test this out by running the game and waiting for 4 seconds as we move around. And you can see Brain starts to say his speech on a loop. And when he does so, it doesn't interrupt gameplay. We can make things a little bit more interesting. First of all, I'll just raise this engine wait now that we've demonstrated it to say about 10 seconds. And then we'll vary up the speech so that he says something different each time. So at the moment we have a single dialogue play speech action, and what I can do is just duplicate this a couple of times and type in different speech text for each. So maybe the second one will be, "I really don't like giant lasers." And the third can be, "I'm still in mortal danger here." At the moment, we're just running the first speech action directly from this engine wait. But if we unset this and instead run a different action, which we can do by dragging the output socket into some new space, and here we can create a variable run sequence action, and this allows us to run different action outputs each time it gets run. So I'll set the number of possible values to 3, and you can see we now have 3 different sockets, and each time this is run, it'll run a different one of those outputs. So I'll set my first socket to our first speech, and likewise for the second and third. And for the other 2 speech actions, I'll reroute this back onto our first action. If we want to help declutter our action lists, we can do that just by clicking the Auto Arrange button up at the top, and that just arranges things a little bit more neatly. We'll also want to make sure that this background speech doesn't occur while we're actually talking to Brain as part of his interaction. So if we go back to our hotspot and then finding the Talk to Action list, I'll right-click in some empty space, choose Add New Action, and this will be an action list pause or resume. The method will be pause, and we'll be pausing the action list Brain background speech, and I'll set this to be the first action in this chain by clicking the cog icon and choosing Move to Front. It's gotten a little bit lost behind the other actions, so I can click Auto Arrange to shunt everything down, and then we'll just resume this at the end as well. So I'll go down to the end of the third dialog option where we exit the conversation and just make one more action list pause or resume action, and this will be to resume Brain background speech. Now that we have a few interactions set up, we can play around with our interaction method to see what effect it has on the way that our game is played. At the moment, we're using context-sensitive mode, which gives us a one-button interface. So we can hover over any of our hotspots and click with the left mouse button to run its use interaction. And in the case of the chair, we also have an examine interaction, which we can run by right-clicking. We can define what icons are available to us by going to the Cursor Manager, and scrolling down we've got this Inventory Icons panel where we can change or create new icons that can be selected in our hotspots. We can also show the verb involved in each interaction by going up to the hotspot cursor and just checking prefix cursor labels. And you can see now we have Use Chair and Talk to Brain. And if we want to show that we can both use and examine something, we can change the When Use and Examine interactions are both available setting to display both side by side. We can technically create as many use interactions as we want on a given hotspot, but with this mode, left-clicking will only run the last enabled one. We can change our interaction method by going to the Settings Manager, and underneath Interface, we've got this Interaction Method field, and the other modes allow us a little bit more control over having multiple use interactions. So for example, if we choose Interaction then Hotspot mode, this allows us to first select the icon and then the hotspot that we want to use it on. This is similar to the classic Sierra and LucasArts games, and we can demonstrate this by going to the Cursor Manager and clicking Cycle Interactions with right-click. And if we now run the game, right-clicking lets us cycle through the various interactions. To demonstrate this properly, we can create a few more use interactions, let's say on Brain here. So I'll select his hotspot and create a couple more use interactions. One will use the Use icon and the other will use Look At. I'll set the player action for both of these to turn to face, create a couple of interactions for them, and parent them to Brain. And for use, we'll just have our player say something like, "I'm not sure how to free him. I'd better look around." And for Look At, he can say something like, "Brain's got himself in trouble again." Adventure Creator also includes interface templates that give us ready-made interfaces for us to play our game with. And if we go up to the top toolbar and choose Adventure Creator, Getting Started, New Game Wizard, and this time, instead of choosing New Game, I'll choose Modify Existing, we'll then bring up the Templates menu, and you can see, for example, we have 9 Verbs interface, which will give us the classic LucasArts 9 Verbs UI, and more are available on Adventure Creator's Downloads page. Going back to our Settings Manager, We can set our interaction method to custom script if we wanted to entirely rewrite the way that interactions are run, and you can find details on how this works in the manual. But the final option we have here, and the one we're going to be using for the rest of this tutorial, is choose hotspot and then interaction. This allows us to first click on a hotspot and then decide in what way we want to use it. So if we run the game again, we can test this out by clicking on Brain here. And you can see we'll then get the option to use, talk to, and look at, just from a menu that appears above. This menu that then appears is the Interaction menu and is listed in the Menu Manager underneath Interaction. And we'll be configuring this a little bit later. In order to solve this little puzzle we're making, we're going to have the player use an item in their inventory. With the default interface, we can access our inventory by hovering the cursor over the top toolbar, and at the moment we don't have any. But what we're going to work with is an instruction manual showing you how to deal with giant lasers. We can find the graphics for this inside our tutorial files folder, and then choosing Evil Layer, Set, and then we have an instruction manual model file, as well as an icon for it inside textures called Book Icon. To create an item that appears in our inventory menu, we can go to the Inventory tab of our game editor, and with the Items sub-tab selected, we can click Create New Item and give it a name. So we'll call this Instruction Manual. And we can give it the main graphic, Book Icon. And we'll have it so that the player has to find this, but just to demonstrate how this appears, we can temporarily check Carry On Start. And at runtime, we can hover over the inventory bar to see it, and click on it to then use it on a hotspot. I'll uncheck Carry On Start again, and next we'll have the item appear somewhere in the scene. And I think we'll put it over on this coffee table here. So if I go back to our Set folder and drag in Instruction Manual over onto this coffee table, I'll rotate it and position it a little bit up. As before, we can make this interactive by attaching both a collider and a hotspot component. So I'll add a box collider and then choose Add Component, Adventure Creator, Hotspots, Hotspot. We'll have the player walk over before picking it up, so I'll create a new Walk To marker, which I'll position just in front on the floor here, parent it to the hotspot, and then as I create a new use interaction, set the player action to Walk To marker. I'll create a new interaction action list, again parent it, and we'll do this in a very simple way first and then make it a little bit more complex. So to begin with, we'll just have the player say something. So we'll run a dialogue play speech in which the player says, "Death, lasers, and you could be useful." Next, we'll add the item to our inventory by running an inventory add or remove action. By default, we're already set up to add the first item defined, so it's already going to add the instruction manual. And next, we'll remove this object from the scene, and we can do this with an object add or remove action, where the method is remove, and the object to delete is instruction manual. This will need to be the last action in this chain because I've parented the action list to this object. And let's now run the scene and see how it looks so far. We can make things a little bit more interesting. First of all, I'm going to go back to the hotspots label and call it maybe Mysterious Book. And we can also give a look interaction by clicking the plus and choosing Look At as the cursor. I'll set the player action to turn to face, and I'll have the interaction just be a simple dialogue play speech, where the player says, "I wonder what that is." For the use interaction, we can have the player play a little animation, and we've got something to play inside our evil layer tin pot folder. And if we expand our robot model, we've got a take book animation, and you can see it holds it with his left hand. So what we want to do is play this animation and also parent the book to his left hand. For the animation, we'll need to update his animator controller, which we can find in our 3D Primer folder, and then we've got Player. I'll do a little bit of housekeeping and put these into a separate subfolder. So I'll create a new folder called Player and move both the animator controller and our player prefab into it. I'll click on the player animator and then drag in our take book animation. And to play this from the motion state, we'll use a trigger. So I'll create a new trigger parameter named take book and use it in a transition from motion. I'll uncheck has exit time and give it the condition take book. To have it go back to our motion state afterwards, I'll create another transition, and this time leaving the settings as their defaults. With this animation set up, we can now return to our use interaction. I'll right-click in some empty space, choose Add New Action, and this will be a character animate action where we affect the player, and as before, we'll be changing a parameter value. The parameter to affect will be take book, and the parameter type is a trigger. Next, to have the player hold the book, we can run a character hold object action. Again, we'll be affecting the player. The hold method will be parent object to hand, and the object to hold will be our instruction manual. The attachment point will be left hand, but we'll need to make sure that this is defined in our player prefab. So I'll go back to our player, and you can see further down their inspector we have a couple of fields for left and right hand transforms. In our characters hierarchy, you can see we've got a couple of empties called hold, and these are just children of the hand that just allow us a bit more fine control over where such objects are positioned. So I'll select hold L as the left bone transform and hold.R as the one for the right. With this action now configured, I'll have it run the first action we're currently playing and then move this character animate to be the first one in our action list. Testing this out again. When we click on the mysterious book, we have the option to both use and look at. And you can see actually the animation is playing at the wrong time. And the reason for this is that our talk animation is trying to start at the same time as the take book transition. There's a few ways we can solve this, but the way I'm going to go with here is just to have our take book animation transition from our any state instead of motion. And that'll just mean that the motion state isn't also active at the same time. So I'll remove this transition from motion to take book and add it to any state instead. With our inventory item now being held, we can click on it and then click on hotspots that we wish to use it with. So let's make an interaction between the book and brain here. With our brain hotspot selected, we can have hotspots react to inventory items just by going down to the Interactions panel and clicking the plus icon beside Inventory Interactions. These types of interactions will have an additional inventory item field, and so this interaction is tied to our instruction manual. I'll have the player action just turn to face, and for this interaction, again we're just going to have some simple speech in which our player character says something like, "I don't think he wants to read it himself." With our current interaction method, we can also run this interaction by clicking Brain directly. The inventory item will be listed as an additional icon. Now that the player is able to make a change to the scene by way of picking up the book from the coffee table, it's a good time to talk about Adventure Creator's save system. By default, we can save and load our game by going to the menu button here, or by pressing escape, and then accessing either save or load from the pause menu. If I save the game, I'll create a new save, and so long as the scene is added to Unity's build settings, that'll then save the game, and we'll get a note about it in the console here. If I exit the game now and then restart, we can demonstrate what this has done by going to the same place, the pause menu, and then choosing load. And if I load this save file, you'll see that a few things have happened. First of all, the player's position has been restored. The book is in our inventory, but there are a couple of things that weren't quite right. The first is that the camera didn't snap. It had to transition all the way from the other side of the scene to where it is now. But more importantly, the book is still on the table over here. And that's because when it comes to scene objects, Adventure Creator needs to be told what kind of data it needs to save. In the case of this book, when we pick it up, we remove it from the scene, so we'll need to tell AC that this game object's presence in the scene needs to be recorded. Assigning such data is a case of attaching the correct remember component, and if we select the book here, we can go down to the Add Component menu and choose Adventure Creator and then Save System, and we'll then get a list of all of the remember components available to us. These are all detailed in the manual, but the one we want to use here is the Remember Transform component. This component mainly just saves the position and rotation of an object, but we can also use it to save the object's presence in the scene. And we can do that by checking Save Scene Presence. As we do so, we'll get a little help box giving us a warning about a particular option in the Settings Manager that it wants us to check. This is the Always Reload Scene when loading a save file option, and we can find this in the Settings Manager, down at the bottom, underneath Scene Loading. This is necessary so that whenever we load a save file, it will reload the scene and respawn this book automatically. Going back to this Remember Transform component, you can see further down it's listing a constant ID number, and this is a unique ID number that AC uses to keep track of it. You can see it's also represented by this save icon in the hierarchy. This ID number is needed for any camera that could be active during gameplay, and we'll get a warning about it in the console if this isn't the case. So we can go back to our game camera array and then add the component Adventure Creator Save System Constant ID. We can test out these changes by rerunning the game. I'll quickly move over to the coffee table and then pick up the mysterious book. Then I'll resave over this save one we've made. To demonstrate this properly, I can exit play mode and re-enter so that we're positioned somewhere else in the scene. And I can go to Menu, Load to load that save. And you can see this time the camera snapped instantly. We have our book in our inventory, and the copy of that book on the table is no longer there. This whole concept of flagging up scene objects with the correct data might be a little bit confusing at first, but fortunately Adventure Creator can actually automate this process. It's just a good idea to be aware of how this whole system works. We can demonstrate this by going back to the instruction manual, and I'll remove the Remember Transform component. And if I then go back to the Settings Manager, up at the top we have a Saving section, and we can click Auto Add Save Components to Game Objects to have Adventure Creator go through all of the scenes and add all of the Remember components that it's guessing that it needs to. And if we now go back to our instruction manual, you can see we've got the Remember Transform component back with Save Scene Presence checked. It's also gone through and added a few other components you can see listed in the hierarchy. So for example, in the case of the laser gun, where we have a variables component, it's also added remember variables that allows any variables defined here to have their states saved. So far as our background speech goes, action lists are reset upon loading a save, so we just need to go back to our brain background speech and inside action list starter, check run on scene load. Now that the player is able to pick up this instruction manual on giant lasers, we can have him use it on this panel here to turn off the laser and solve our game's little puzzle. Just as we've done before, I'll make this panel a hotspot. So first I'll select it in the hierarchy, and then in the scene manager, I'll click to create a new hotspot, choosing to position it over the selected mesh. I'll name this hotspot panel, give it the label, if not name, as panel, create a walk to marker, and reshape the hotspot itself so that it better fits the panel. For this hotspot, we're going to have a couple of interactions. One will be a regular use interaction, and the other will be an inventory interaction that runs when we combine it with the instruction manual. For both of these, we're going to have the player action be walk to marker, and I'll create the pair of interaction objects and put them in the hierarchy. For both of these interactions, we're going to do something a little bit more complex, and we're going to play multiple animations at once and do a little bit of camera work as well. If we go back to our tutorial files folder and then find the EL tinpot file, we can expand the model to see some of the animations we've got. And for the use interaction, we'll play this press button animation. And if we preview this, we can see that our player just presses one of these buttons, and we're then going to play some other animations afterwards. So what we're going to do is use Timeline for this, and Timeline is Unity's sequencing tool, and it's generally a good option for whenever we want to have different animations and maybe sound and camera work all synced up together. Going back to the 3D Primer folder, I'll create a new folder named Timelines. And working on this use interaction first, I'll create a new timeline asset named panel use, and I'll drag and drop it into the scene to create a playable director. I'll make sure play on awake is unchecked, and I'll put it inside my hotspot panel hierarchy. I'll double click on this playable field to open up the timeline window, dock it down here, and then click on the lock icon so that I can still select other objects. We're going to first animate our player, and because our player is spawned in at runtime, we're going to have to use a temporary copy of him. So I'll go back to the player folder and just drop him into the scene file here. I'll put him around about where this marker is, because this is where he'll start the timeline from, and then I'll drag his model file into the timeline window. I'll choose Add Animation Track, and then going back to the tinpot model file, I'll drag and drop this press button animation into this track. I'll have it run maybe a few frames after this has begun. And as a result of clicking this button, we're going to have the laser actually moves in the wrong direction and gets a little bit too close to brain. So I'll drag the laser gun as well into the timeline window, choose Add Animation Track, and we can find an animation to play inside the Set folder, expanding laser gun, and we've got laser gun move up. We're not going to be so cruel to brain, we'll give him a chance to get out the way, and we can find an animation for him inside his model file called Dodge Laser, and we can play this by dragging his character from the scene into the timeline window, again choosing Add Animation Track, and then assigning this Dodge Laser. We can spend some time tweaking these various tracks to get the timing exactly right, but we want it to generally play something like this. To make this a bit more cinematic, we can have a couple of new cameras. I'll go to the Scene Manager again and create a couple of stationary cameras. I'll name this Panel Cam 1 and Panel Cam 2. To preview this camera while I'm working on it, I'll temporarily enable the camera component and dock the game window down at the bottom here. So we'll have Panel Cam 1 is looking towards Tin Pot from the other side of the panel, maybe something like this, and lower the field of view a little. And for Panel Cam 2, I'll position it so that we get a good view of the action. Going back to our timeline, to control the camera, we can right-click and choose AC Main Camera Track, and then we can just drag each of these cameras into the space. To have this camera change be previewed in edit mode, we'll need to make sure that the only camera active in the scene is that of the main camera, so we'll need to disable the other camera components. I'll go back to the two panel cams and disable the camera component there, and I also need to do this to the various cameras for our game camera array. You can see now we're viewing the Panel Cam 1, and when we get to about here, we'll cut to Panel Cam 2. So I'll move this transition to be a little bit earlier, and I think this looks about right, and then end Panel Cam 2 sooner as well. I think when we get to about this point, we can have Brain give out a little yelp, and we can do that by creating a new AC speech track. And you can see with this inspector, we require a speaker prefab, and this is because timelines are asset files, but we made a prefab for our NPC back in our Brain folder. So I'll drag this EL Brain into the prefab field, and then I can right-click in the track, choose Add Speech Playable Clip, and we can then have speech text show whenever this clip is active. I'll lower the duration so that it's quite short, and give it the line text, "Whoa!" We can also preview subtitle text in the game window, so we can get a good idea of how this timeline is now looking. Going back to our panel hotspot and opening up the user interaction, we can play back this timeline by creating an engine control timeline action, where the director is going to be panel use, and we'll check wait until finish so that the game is in a cutscene while it's running. We still have the temporary player we added to the scene to create our animation track, and if I remove this now, you'll see that that animator field has now become empty. But we can easily fix this by having our action remap the binding. If we go back to our engine control timeline, we can check remap bindings, and we'll then have the option to rebind any of these tracks to a different object. This first animation track is the one that relates to the player, and in fact we can be sure of that by renaming this track Player Animation. And to remap it to our player prefab, we just need to check Bind to Player. With this action now complete, we can test it out by going over to the panel here and clicking Use. And I think I did forget actually in the hotspot panel to make sure that face after moving is checked for both of these interactions. And now we can move on to the second interaction, which is the one where we use the book on the panel. This too will be an engine controlled timeline action, and we can create the timeline inside our timelines folder by choosing Create, Timeline, and then Timeline. I'll name this Panel Book, and again drag it into the scene so that it creates a playable director for it, uncheck Play on Awake, and make it a child of my hotspot. With this object selected, I'll unlock and relock the timeline window so that it's snapped to this playable director. And as before, we can use a copy of our player object. I'll drop him into the scene and drag it into an animation track. As before, we have some animations that we can play here. So going back to our TinPots model file, we see the animation slam panel, where you can see our player essentially brute forces the problem by just slamming the book onto the panel. This is going to need a bit of parenting because we're going to have the book in the player's hand, but that'll be handled through actions, and we'll focus on the timeline first. So I'll drag the slam panel animation into the track here, and a few frames later we'll have the laser turn off. So we'll animate the laser, and this time we'll run the turn off animation. And again, we'll have some camera work, so I'll create a new AC main camera track, where I'll recycle the panel cam 1 we had from before. And then we'll cut to, I think, a wider view of panel cam 2. So I'll create a copy of it, name it panel cam 3, and just move it a little bit further up. And zoom out a little bit. As before, I'll rename our players track as player animation, and then remove the player from the scene. I'll go back to our panel instruction manual interaction, and we'll set the director to panel book, check remap bindings, and remap the player animation track to the player, checking wait until finish as well. As mentioned, we're going to have the player holding the book while this timeline plays, and we can do that by using a character hold object, just as before, where the player is holding the book in his left hand. The last time we were using this, we were doing so with the instruction manual object in the scene, but by the time we run this timeline, we'll have already removed this manual from the scene, so we won't be able to use this scene object. Instead, we can make a prefab and then spawn in a copy while the timeline plays. To do this, I'll get the instruction manual here and just make a prefab by dragging it into my 3D Primer folder. This prefab also has the hotspot and box colliders we created earlier. We're not going to need these, but it's not going to do any harm because we're going to remove it afterwards. So back in the action list editor, we're going to start this action list with a object add or remove action. The method is going to be add, and we'll be instantiating this instruction manual prefab. I'll set this to the first action by choosing move to front, and then I'll have it run the character hold object by dragging the wire onto it. Having spawned this prefab into the scene, we then want to use that scene instance of that prefab as the object we're holding. In order to do that, we can make use of a parameter, and parameters are essentially like variables for action lists. We can define them in the properties panel of an action list, and then checking use parameters. I'll click to create a new parameter. This is going to be named spawned book, and it's going to be of the type GameObject. You can see our object add or remove action has now been updated with an additional send-to-parameter field, and if I set this to spawned book, it means that the spawned copy of this prefab will be set as this parameter's value, and we can use it in the character hold object just below. For any action that has a valid parameter, we'll get a little P button beside it, and if we click on this, we'll then have it be overridden with a specific parameter. So in this case, we're going to be holding the value of spawned book. We can also use this parameter to control which object we remove afterwards. So if we go down to the bottom here, and I'll create another object add or remove, and this time we'll run the remove method, and the object to delete will be overridden again by this spawned book parameter. Now that we're able to solve this game's puzzle, it would be nice if the scene reacted to the change that it made. For example, we'd like Brain to be able to stop calling out for help, and he can maybe say something different if we want to talk to him again. Earlier on, we added a variable to this laser gun. We attached the variables component and used it to define a bool named isLaserOn. This variable is already used in the background speech conversation so that it stops running once the variable becomes false. This change should happen once we've used the book on this panel here. So if we go back to our panel instruction manual interaction, we can go back and add a new action to the front of it. This time it'll be a variable set action. The source will be component. The component will be laser gun. And the variable will be isLaserOn. We're going to set this value to false, and I'll click to move to front and auto arrange, and this will then stop that background speech from playing. It's also possible to rerun this interaction by using the book on the panel again, and the easiest way to fix this is just to disable the hotspot. I'll make this change at the bottom of the action list, making a new action, and this will be a hotspot enable or disable, and the hotspot will be panel, and the change will be disable. To record the change to this hotspot's enabled state, we'll need to make use of Adventure Creator's save system again, and we can do this by using the component Adventure Creator, save system, and then remember hotspot. In the case of Brain here, we have our talk to interaction, and you can see that in the middle dialog option, Brain asks us to turn off the laser, so we can have him say something different if we've already done that. I'll move some of these other actions out of the way and make use of another variable check action. Again, we'll be checking the laser gun component variable, and if it's set to true, then we'll have the speech play as normal. If not, we'll have a different line play where Brain says something like, nothing, I'm fine now. And I'll link this up to the rest of the chain. In the case of this laser gun here, when we run the book interaction, we animate the laser powering down, and so we're going to want to save that change in animation as well. This can be done with the Remember Animator component, but in this case it is a little bit more tricky because this component works by saving the state of its animator controller. At the moment our laser gun doesn't actually have one because we control all of its animation using timeline. So what we'll need to do is give it a controller and then have it be able to play an off animation inside. I'll go back to our 3D Primer folder, create a new animator controller named Laser, and I'll assign it to the laser gun. And opening up its animator window, we'll have a couple of animations going back to the set laser gun asset file. We've got laser gun on and off. We'll have it be on by default, and we'll turn it off with a bool variable. So I'll create a new parameter named laser on, and I'll create transitions that use it to go back and forth. Both of these will have no exit time or duration. Going from on to off, we'll use the condition laser on is false, and the opposite for the reverse. To update this parameter's value, we can either go back to our panel's interaction and add an object animate action to control its value, but an easier way is just to synchronize the parameters value with this variable here. I'll scroll down to the Add Component menu and choose Adventure Creator, Logic, Link Variable to Animator. And for this component to work, we need to have both the parameter and the variable use the same name. The variable is named isLaserOn, so I'll rename this parameter to match. I'll type that into this shared variable name box, and then assign the variables to it as well. Having made these changes, our game will once again work with the save system, and our various interactions have been affected as well. So we can no longer use the panel, and if we go and talk to Brain, and choose the middle option, he'll give us a different response. Now that we've created the main puzzle and its logic for our game, we can start to focus a little bit more on polish, starting with the opening cutscene. For this intro, we can focus on this lift here, and we'll have the lift doors open, the player step through, and do a little bit of camera work as well. For this, we'll use Timeline. So going back to the 3D Primer Timelines folder, I'll right-click and choose Create New Timeline Asset. I'll name it Intro, and as before, I'll drag and drop it into the scene and uncheck Play on Awake. If I double-click on the Playable field, we'll bring up the timeline window, which I'll then lock. And the first thing we're going to do is animate our lift doors. So I'll go back to the tutorial files, Evil Layer, and then Set. And we have this lift model. And if I expand it, we've got a few animations we can use. I'm just going to use the Open animation, which we can use by first dragging the lift itself into the timeline window and choose Add Animation Track, and then drag the Open animation into that timeline. To have the player walk through, we'll again need our player prefab. So I'll go back to 3D Primer, Player, and then drag in our player prefab. This time we'll need to animate his position using keyframes. So I'll drag and drop the player into our timeline to create another animation track, and then click Record so I can make some keyframes. Just after the lift doors have opened, I'll make sure he's positioned just inside, facing outward, and a few frames later, have him cross over the threshold into the main room. I'll come out of record mode, and we can then have the lift doors shut again by going back to the lift model, and I'll drag and drop the close animation. While the player is moving through the doorway here, we're going to want him to play his walking animation. We could do that with a separate animation track where we line up his idle and walk animations, but Adventure Creator gives us an easier way to do this, and we can just go to the plus icon to create a new AC Character Animation 3D track. If I right-click and choose Add New Shot, and then have it span the whole width of this timeline, this will cause him to blend between his various idle, walking and run animations automatically based on his speed throughout the timeline. And it's then just a case of making sure that the player is assigned in the character field. As before, our two player-related tracks will need rebinding, so I'll name them appropriately so that we can find them later. I'll name the first Player Movement and the second Player Animation. For the camera, we'll create a new camera that we can animate. I'll go to the Scene Manager and create a new stationary camera, which I'll name Intro Cam, and then reference it in a new AC main camera track. Again, I'll have this span the whole width of the timeline, and I'll reposition it so that we've got a good shot of the door. Although the inside of the lift is just static geometry, we can create the illusion of the lift having moved downward by just animating our intro cam. So I'll create a new animation track, and then with the record button, I'll create a new rotation keyframe by right-clicking the rotation field and choosing Add Key. And a few frames before, I'll just raise the pitch a little. For a nice transition from our intro cam to our gameplay, we can just add an ease out duration to our main camera track. And it would also be nice to have the camera fade in from black at the start. We can do this with an AC camera fade track. And if I right click to create a new shot from a Texture 2D, I'll use the black texture that comes with Adventure Creator. And you can see that whenever we are over this clip, the game window will just take this texture. So to create a fade, all we need to do is give it an ease out duration, and that'll cause a fade during that transition. With this timeline finished, I can close this window, as well as remove our temporary player from the scene, and we can then create a cutscene to play it from. This is going to be our game's opening cutscene, and we can play this very easily by going back to our scene manager, and underneath Scene Cutscenes, we can click the plus icon beside On Start. And this will generate a cutscene named On Start, which will play whenever this scene begins through natural gameplay. I'll open up the editor for it, and as before, this will be an engine control timeline, with the director this time is going to be intro. We'll be waiting until finish so that it's a cutscene while it plays, and we'll also need to remap the player's bindings. So I'll check Remap Bindings, select each of the 2 player tracks, and check Bind to Player. In the context of a proper project, we'd probably only want to run this timeline if we were beginning this scene having just come from a specific other scene, and we can do that by beginning this action list with a Scene Check action. And this allows us to check the details of the previous scene either by its build index number or its file name. And on the topic of scenes, we can also change the active scene by using the Scene Switch action. As this is our On Start cutscene, we can test this out right away just by entering play mode. It's helpful to be able to skip this opening cutscene while we're testing, and also give that option to players as well. If we go back to our Settings Manager and scroll down to the Input panel, we can find a list of inputs that are available to us based on our game's settings, and you can see near the bottom we've got one named End Cutscene, and if we press a button that is named this, it'll cause the cutscene that's currently running to be skipped. The method of creating inputs is down to our project's active input handling, and in Unity 6.2 and beyond, the default is to use Input System. At the start of this tutorial, we used the New Game Wizard to import the Input System integration template, and we can find that back in our 3D Primer folder, and then in the Input System subfolder. You can see here we've got a controls asset, and if I double click it to bring up the editor for that, you can see we've got a listing for End Cutscene, and if I expand it, by default it's mapped to the Tab key, and if we want to modify this or create new inputs that are listed in the Settings Manager, this is the panel to do so from. So if we rerun the scene and rerun this opening cutscene, I can press Tab at any time to skip that timeline. This input also works for any action list that blocks gameplay. So for example, if we come over and talk to Brain, I can press Tab to skip through all the various dialogue. So far, we've been using our Game Camera Array camera type to control where the camera is as the player moves around the scene. For a more traditional over-the-shoulder camera, we can use the third-person camera type, and this is available in the Scene Manager underneath the Camera section. We can click to create a new third-person camera and then make it the default by assigning it in the Default Camera field. This is a complex camera type, as reflected by its inspector, but much of these values can be left as their defaults for a character of standard size. The one thing we will change to begin with, though, are the input axes, and you can see by default our spin input axis is set to horizontal and the pitch vertical. By default, these will relate to the cursor keys, or WASD, so if we want to turn with the mouse cursor, we're going to have to use different axes instead. To work out what inputs we need, we can go back to our Input System folder's Controls asset, and you can see we have in the UI action map, we already have a couple of actions that are mapped to the mouse, and these are named Cursor Horizontal and Cursor Vertical. So if I name these in the Game Camera's inspector, I can set the spin input axis to Cursor Horizontal and the pitch to Cursor Vertical. If there are any other values we want to tweak, the best way to do it is to see what effect they have at runtime. So if we wanted a horizontal offset, I can increase that value and see what effect it has, and then just copy the component, come out of play mode, and paste those values back in. With this new camera mode, we do find a few issues related to hotspots, and the first of these is related to distance. So we can hover over the chair here for quite a way away, and we're still able to do so even when the cursor is blocked by this wall. To fix these, we can go back to the Settings Manager. Scrolling down to the raycasting settings, we can reduce the hotspot ray length to 10, and to have our wall act as a blocker, we just need to make sure that it has a collider placed on the default layer. If we go back to our scene window and select this wall here, you can see that we've got the wall and the floor all as one mesh, and currently this is on the nav mesh layer, and this was so that we could test out point and click pathfinding earlier, but as we're not using that anymore, we can just set it back to the default. The other hotspot issue we're facing is that we are now using the mouse to control both the camera and the cursor, and so the two are kind of competing with one another, making it a little bit awkward to select hotspots. What we can do is lock the cursor in the middle of the screen, and then have it unlock when we want to click on one of our interaction menus. We can have our cursor be locked by default by going back to the Settings Manager, and this time in the Interface panel, we can check Lock Cursor in Screen Center when game begins. With this change made, the cursor is now fixed in the middle of the screen, and it'll unlock automatically when we press Escape to open up the pause menu. In the case of the interaction menu, however, when we click on it, the cursor does not unlock, and that's because the interaction menu doesn't pause the game. So we'll need to manually unlock the cursor as this menu turns on, and relock it again when it turns off. We can do this from the Menu Manager, and the Menu Manager is the last tab in the game editor. The Menu Manager has a list of all of the menus that make up our game's interface, and if we select the Interaction menu, we'll then get a list of its properties. You can see within them we've got a couple of action list fields that will run when the menu is turned on and off. So if we click the plus icons beside each of these, this will create a pair of asset files. These are action lists just like the cutscenes we've already been working with, only they exist as asset files, meaning we can run them from any scene. I'll put these into a new folder inside 3D Primer, named Action Lists. And we can then edit them by double-clicking. In the case of the Turn On action list, this is when we'll want to unlock the cursor, and we can do this with a player constrain action, and we can set the cursor locked field to disabled. For the turn off, we'll do the opposite. We'll run another player constrain action, this time setting the lock to enabled. With that change made, we can now move over to Brain here, and if we click, we'll have free reign of the cursor to let us be able to choose an interaction type. You can see though that the camera is still moving as we move the cursor, and if I move the cursor a little bit too far, the menu turns off automatically. To fix these two things, we can first go back to our camera, and right at the bottom we can check Input requires locked cursor, and that'll prevent it from moving when our cursor is unlocked. And to stop the menu from turning off, we can go back to our Settings Manager, and underneath Interface we can change the Close Interactions with field to Click Off menu. As a final bit of polish, we can have our third-person camera's orientation match that of our opening cutscene. You can see if I run it by default, it will transition to the global forward direction. And we can change this by once again going back to our third-person camera's inspector, and scrolling down to the bottom, we can check Set Initial Direction when active, and the initial direction to previous camera spin. With our new third-person camera, our game is starting to have a bit of polish to it, but it is a bit awkward to have to center the cursor over hotspots right in the middle of the screen like this. So now would be a good time to really delve into some of the options that AC offers so far as custom interfaces go. Scrolling down towards the hotspot section of the Settings Manager, you can see we've got a hotspot detection method field. At the moment, this is set to mouse over, which means hotspots will be detected according to the cursor hovering over them. We could instead set this to player vicinity, which means they'll become selected as the player moves towards them. For this tutorial, however, we're going to go with custom script because AC offers the ability to control hotspot detection as well as a wide variety of game settings through script. We're not going to be doing any scripting, but instead we're going to take advantage of a pre-made template that we can find on the AC website. We can get this by going to the same place we got the tutorial files. If I go to the top toolbar and choose Adventure Creator, Online Resources, and then Downloads. And on this page we have a number of templates, and the one we're going to use is Screen Space Hotspot Detection, and this is inspired by Revolution's Beyond a Steel Sky. I'll download this and then import it into Unity. Because this is a template, we can install it using the New Game Wizard, just as we did when we first set up our game. So I'll go back up to the top toolbar once more and choose Adventure Creator, Getting Started, New Game Wizard. Because we're working with an existing game, not creating one from scratch, I'll choose Modify Existing on the second page, and will then be presented with all of the templates available to us. You can see halfway down we've got Screen Space Hotspot Detection as an option, so I'll tick the box beside it and then click Create, and that template will then have been installed. This template has made a few changes, mainly to the menus, and we can see those in the Menu Manager. Scrolling down to the bottom, you can see we have new hotspot and interaction menus, as well as the old ones that are now disabled and given the suffix old. If we now try running our game again, if we hover over the panel here, we don't need to have our cursor be directly in the center of the screen. Instead, hotspots are selected when they're within a circle in screen space. Clicking on a hotspot will then reveal its interactions underneath the name of it, which we can then click as we did before. We will need to make a few changes, however. You can see, for example, when we hover over Brain here, he's not being detected, and that's because we need to raise the detection distance. Back in edit mode, you can see that in our 3D Primer folder, we have a new directory that the template created, and if I go into this, there's a new hotspot detector prefab that we can double click to edit. I'll raise the distance to maybe say 6, and here we can control other options like the size of the screen circle, but I'm going to leave these as they are. You can see that Brain is now selectable as he was before. In the case of the laser here though, it's a little bit too far away no matter where we're standing for it to be detected, and while we could increase the distance yet more, we don't want that change to be applied to other hotspots as well. So what we can do here is rely on an interaction boundary to control exactly where the laser can be detected. Back in edit mode, we'll want to work with the hotspot of the laser gun, and an easy way to do this now that we're getting a little bit cluttered in our hierarchy is to go back to the scene manager and right-click the hotspot field, and this will bring up a list of all of the hotspots in our scene. So going back to hotspot laser, you can see we've got an interactive boundary field, and if I click on this to create a new one, this appears as a cube just around that hotspot. So if I position this on the ground here and stretch it out and then run the scene, we'll find that the laser is now interactive whenever the player passes through that box. Having changed the appearance of our interaction menu, we can do something similar to our subtitles menu so that our UI feels a bit more consistent. First of all, I think I'll disable the scrolling of speech text, and we can do that from the speech manager and uncheck scroll speech text. The speech manager is where we can control things like lip syncing, speech audio and translations, but we'll go over this a little bit later. The display of subtitles themselves are handled in the subtitles menu, and so we can find this in the menu manager by clicking on the subtitles menu. This will then give us the properties of that menu, as well as the two elements that it contains. You can see we've got a speaker label which shows the name of the character, and a line label that shows the speech text. Menus can be rendered in a couple of ways, and this is determined by the source property towards the top. You can see this is set to Unity UI prefab, which means we're using Unity's built-in UI system. If we instead set this to Adventure Creator, then we'll be using AC's internal rendering system, and we can preview this by just looking at the game window. And you can see here we've got our subtitles, and I can control its appearance by modifying the properties within the menu manager. This way of working generally is better for rapid prototyping because it's relatively quick to get up and running and previewing. But for more polish and stylistic control, it's always better to rely on Unity UI. So I'll set the source back to Unity UI prefab, and you can see with this mode we have a linked canvas prefab field that if I click will ping the subtitles UI asset that displays the actual text boxes. So we can restyle this menu by clicking on these various text boxes and controlling their properties. So for the speaker label, maybe I'll align it to the left, put it in italics, and maybe change the font to Legacy. I'll do the same font change for this subtitles box. And if we come out of this prefab and go back to the menu manager, you can see that clicking on each of these elements brings up further properties that we can use to control it. So if we click on the speaker element here, we can click on Use Character Text Color to change the color of the text based on which character is speaking. This is a property inside player and NPC components. So if we wanted to change the color for Brain here, we could click on his inspector, go down to NPC, and underneath speech text color, change it to a nicer light blue. Our subtitles are starting to look a bit better now, but you can see that whenever Brain speaks his background speech, it's using that same menu, and it would be helpful to be able to distinguish between background speech and speech coming from cutscenes. We'll also find that if we move further away from Brain, we're still getting that same background speech appearing, even though technically we shouldn't be able to hear it. We can first of all prevent it from showing background speech by going back to its properties and setting the For Speech of Type field to blocking only. We can then create a new menu just to display background speech. So further up, I'll click on Create New Menu and name this Background Subtitles. To be consistent with the rest of the game, I'll choose the source as Unity UI Prefab, and the appear type is going to be when speech plays. This time I'll set For Speech of Type to background only, and if I check duplicate for each line, then we'll get further options to give us more control. So I can use the speaker proximity field below to limit the menu's display only when we're within a set distance from this character. So I'll set limit by distance to player, and then set the max distance to maybe 15. The position type controls how the menu is repositioned at runtime, and I'll set this to above speaking character. We'll come back to these other fields in a moment, but first we'll create the label that will display the subtitle. So at the very bottom, underneath the Elements section, I'll create a new element of type Label, and I'll set the label type to dialog line. Next, we need to create the Unity UI canvas that will display these in. So I'll go to Game Object, UI, and then Text. We're going to use TextMesh Pro for this menu. And if we haven't already, we'll need to import the TMP Essentials. I'll name this canvas Subtitles Background UI. And you can see Unity's also created an event system, which we don't want because AEC will provide its own. I'll position this text box in the middle here, and then play around a little with the controls. So I'll reduce the font size, have it be aligned in the very middle, and maybe stretch out the box a little bit as well. We'll then need to make this a prefab, and I'll put this in the same folder as the rest of them. So inside 3D Primer, we've got a UI folder. So I'll drag and drop it into there, and then remove it from the scene. Going back to the menu manager, we'll then just need to link this all up. So our linked canvas prefab is going to be Subtitles Background UI. And to link the other fields, we'll need to open this up in prefab mode. You can see for the label, we've got a linked text field, and we're not using a text component, we're using TextMesh Pro. So we just need to check Use TM Pro components further up. I can then drag our text into the link text field, and you can see it's recording a constant ID number similar to the way that the save system works. One last thing is to set the rect transform boundary, and this is necessary if we want to be able to reposition menus at runtime. This is typically the first immediate child of our canvas, and in this case it's the text object again. If we were making a more complex UI that has more elements in its hierarchy, we typically want to create a shared parent in between the visual elements and the canvas root. At runtime, you can see our background speech is now appearing separate, but there is a slight problem, and you can see that it's actually being repositioned to the center of the scene here. This is not normally the case, but Brain's a little bit unique in this case, because while he's displayed on the table here, his root object is actually positioned at the origin. So to fix this, we can assign an override to display subtitles from, and if we go to the inspector, underneath the NPC component, we've got a speech menu placement child field. So let's just create a simple empty child object. I'll name it speech override, and I'll position it so that it's just above his head around here. I'll go back to the NPC component and then just assign that in this child field. And then at runtime, his background speech should then appear in the correct place. Another common aspect of adding polish to an adventure game is to provide speech audio for the various characters. Adventure Creator can handle this from within the Speech Manager. And if we go down to the bottom, we have a game text panel. And you can see at the moment we've gathered 0 lines of text. So what we need to first do is have Adventure Creator go through our project and find all of the game's text. We can do this from the Gather Text button, and we'll then get a prompt to save and back up our game. And when we click OK, it'll go through all of the scenes in our build settings and then report how many entries it's now added. You can see we've now got 83 lines, and if we scroll down, we'll now have filtering options to view them. So for example, we can set the type to hotspot and the scene filter to any or no scene, and we'll then get a list of all of our hotspots. If we set this to speech, we'll get all of our speech text, and clicking any of these entries will give us more details. So in this case, we've clicked on one of Brain's lines, and you can see we have fields for an audio path and a file name, and that's because the default way of associating lines with audio is to put those audio files inside resources folders. So to create audio for this line, what we would do is go to our assets folder, choose a new folder called resources. Inside that folder, create another called speech. And if we then dropped in an audio file named elbrain109, that clip would then play whenever this line appears. This is only the default method, and we do have a few other options. If we scroll up to the speech audio panel, you can see we've got a reference speech lines field, and at the moment this is set to by naming convention. If we change this, for example, to by direct reference, then our fields at the bottom would then become audio clips that we can just assign assets directly to. The most performant option, however, is to rely on Unity's addressable system, and we can rely on that by setting this field instead to by addressable. I'll set this back to the default, and going a little bit further down again, you can see we've got a languages panel, and it's here that we can define various translations that our game can support. I can click Create New Translation and give it the name, for example, French. And returning back to our speech text, you can see we now have fields for the French translation as well as the French audio clip. Audio clips are only associated with speech text, but all text supports translations. So for example, if I were to change this back to hotspot and click on Mysterious Book, we have a French field for that as well. It can be a bit time consuming to enter in the translations for all of our text directly here in the Speech Manager, and the better way is instead to export our text as a spreadsheet. If we click on the Export Text field, we'll then bring up the Text Export Wizard, and we can use this to create a spreadsheet that allows us to filter, for example, by different type or by scene, at which point we can export this as a CSV file, make the changes in an external spreadsheet application, and then re-import it via the Import Text button. In the case of speech text, we also have an additional Create Script Sheet option, and this allows us to generate an HTML file that can be given to various actors when they're recording their lines. When we have characters speaking with audio, we generally also need them to be able to animate their mouths as they do so. This is typically dynamic so that the characters' mouths match up with what they're saying, and AC offers a few options when it comes to both lip syncing and facial expressions. While it is possible to animate using either animator layers or timeline tracks, another option for 3D games is to rely on blend shapes. If we have a look at Brain here, and have a look at his model, you can see we've got a blend shapes foldout, and if we expand this, we've got a couple of expression blend shapes and 5 for phonemes. The 2 expression keys control his expression, and the phonemes control the shape of his mouth. AC can make use of these once we've put them into shape groups. We can do this by adding the Shapeable component, and then creating a couple of shape groups, one for expressions and one for lip syncing. I'll set the first one, call it expressions, and the second phonemes. We'll come back to phonemes later, and just going with expressions, I'll create a couple of shape keys. One I'll call happy, and another I'll call sad. You can see that for each key we can choose which blend shapes it relies on, and so for the sad shape we'll set the blend shape to sad and make sure the intensity is set to 100%. If we have others we can mix and match these, but in this case we only need one blend shape per key. The most basic way of relying on this is to use an action, and if we go back to, for example, this hotspot here, right-click in some empty space and choose Add New Action, we can use the Object Blend Shape action. I'll set the Shapeable to Brain, and you can see we can then specify the shape group and expression that we want him to have, setting the value and the transition time. When it comes to having his expression change as he speaks though, it's a lot easier to rely on text tokens that we can insert directly into the speech text. If we return to Brain's NPC component, and near the bottom, we have a Use Expressions checkbox, and if I check this, and then also Map to Shapeable, we can then choose the expression shape group we've just defined, and then create a couple of expressions that match those we already have. So I'll click Add New Expression, name the first one Happy, and then create another named Sad. You can see for both of these definitions we have a replacement token, and it's this that we can insert into our speech text. So I'll right-click and choose Copy Token Text, and then within our action list, maybe when he says "Hey little help," I'll insert it at the beginning so that he looks a little bit more pleased to see us. We can also control shape keys using Timeline. So if we go back to our panel Use Timeline, which is where the laser gets a little bit too close for Brain's comfort, we can have him change his expression as he has to move out the way. We can do this by creating a new AC Shapeable track, assigning our Shapeable as Brain, and then right-clicking and choosing Add Shapeable Shot. I'll reduce the time of this, give it an ease in and out duration, and you can see then in the inspector we have a group ID and key ID to assign. These IDs are listed in the Shapeable component, so if we go back to Brain, down at the bottom, the ID values are to the left of their names, so we want the shape group 0 and the shape key 1. This timeline track doesn't preview, but at runtime this will cause Brain's sad expression to kick in. On the lip syncing side of things, we can go back to the speech manager to control how lip syncing is done. Lip syncing in AC is a two-step process. The first is to determine how lip sync frames are generated, and the second is how those frames are applied. Underneath the lip syncing panel, right now our lip syncing field is set to off. We can use a number of third-party tools such as Pamela, but the easiest, though not necessarily the most accurate, is to use speech text to generate them automatically. We'll then need to choose what lip syncing is performed on, and by default this is Portrait, which refers to a portrait graphic that we can optionally display in subtitles menus. Instead, we'll set this to Portrait and Game Object so that we can apply it to Brain's actual model file. Clicking then on Edit Phonemes will bring up the Phonemes editor, and it's here that we can map our various phonemes to animation frames. We can click on Create New Frame and then start typing a series of phoneme shapes, such as OO or E with a / in between, but we can also click on Revert to Defaults to have these all set up automatically. By default, we have a set of 5 frames, each with their own set of phonemes, and it's these frames that correspond with Brain's phoneme blend shapes. If we go back to Brain's model file, we have our 5 phoneme blend shapes that we just need to assign into new shape keys. So inside the phonemes shape group, I'll click on Create New Shape Key 5 times. The labels don't matter in this case because it's all going to be automated, so I'll just make sure that each of the 5 phoneme shape keys are associated with the corresponding phoneme blend shape. Just like with expressions, it's then just a case of going back to the NPC inspector. And towards the top, under Mecanim parameters, you can see we have a phoneme shape group that now appears, and I'll set this to phonemes. If instead we wanted to rely on animation, we have a couple of parameter fields that we could use to affect our animator controller. As it is, this is now set up, and so when we speak to Brain, he'll animate his mouth as he talks. That's about it for this tutorial. Thank you very much for watching. And be aware that more tutorials, both text and video, can be found on the Adventure Creator website, which you can access by going to the top toolbar and choosing Adventure Creator, Online Resources, and then Tutorials.